culture, healthcare, and then we have studied factors affecting machine productivity,
Okay.
in which we have studied technology, durability, labor, proper workplace, economic situation, and then we have studied factor affecting the system productivity, and
Hmm.
then last was factor affecting to productivity of delivery system, in which type of delivery, machine maintenance, machine users, fuel stability, drivers, traffic situation, etc.
Cool. So those are the stuff what we discussed in last session. Without further ado, we'll move on to the topic of the discussion for the day is basic work content and excess work content. All right. So the today topic for the discussion is basic work content and excess work content. Right. Do you think can you just guess what would be the basic and what would be the excess work? Any idea? So the total work will be content will be summation of both. Right. Yeah. Yeah. Any guesses? What would be basic work
Basic
content?
work is the bare minimum work, while as the excess work is like overtime.
Cool. Anything else?
Basic work is like working with the raw material, and excess is like delivery of that.
Okay. Any other guesses? Any other guesses? Any other guesses? Right. Uh, so what you said is almost right. I'll just define basic work content as basic work content is the irreducible minimum work or minimum time minimum time theoretically or forecasted theoretically required to produce 1 unit of output. So from this, can you interpret now what is actually the minimum work content is or basic work content is? Whatever you said is something related to production process or supply chain, everything. And what we speak here is completely about producing a particular job. That's it. We are not going before the processing or after the processing. It is like we are just speaking only about the work content is only taken in the context of producing a particular job and what will be the time required. That's it. Can you from this particular thing can you just interpret like what will be the actual thing in a basic work content is? All right. So suppose you are going to manufacture this particular product. You design the complete product and calculate the time required for manufacturing each and every component. That is without any flaw in design, without any correction, or without any process defect. So the minimum time required to process this particular product end to end, like 100% efficiency. If you have, there should not be any mistake from labor side. There should not be any labor mistake from the machine side. There should not be any mistake from the management side. There should not be any mistake from the power source, or there should not be any mistake from the material. So if everything is perfect, that particular time required to produce your component, which is completely impossible. That's what all we know is, because practically we have a lot of difficulties in executing the process, because it is not a mere simulation where you can predict the actual time and move on. The forecasting and the actual time varies with the cushion time, because of there are a lot of difficulties, like lot of threshold which happens between the process. So basic work content is something, the time which cannot be reduced at all. So minimum you need this much time to produce that particular component, whatever the component you are producing. That particular content is called as basic work content. So that is how it is defined as the irreducible minimum time theoretically required to produce the 1 unit of output. So this time, whatever you have, you cannot reduce at any card. So the time will be your processing time, like machining time and the processing time, to get the like manufacturing time and the processing time, different process sequence, whatever is required. That minimum time required to get this product output, right? So already I have told like what is total work content is. So basic work content and excess work content. Now from this definition of basic work content, you would have understood what is excess work content is. Any guesses on what would be the exact thing for excess work content? Am I audible? Yeah.
It's like the extra processes acted upon, like smoothing and filing of the like outer surface, making it
No,
beautiful, like
that
paint and extra.
no. That everything comes with the, because that is, those things are the time required to finish your product, right? So that cannot be counted as a excess work content. That is the minimum work content or a basic work content. So whatever you do to improve the aesthetic, because only after doing all the process you get your final product, right? So that cannot be claimed as excess work content. Apart from that, what do you think would be an excess work content?
Maybe designing a product.
Sorry?
Maintenance.
Designing,
Maintenance, designing. What you say designing as work, excess work content?
that means
In what
improving
context?
improving its
Finishing.
looks. Yes.
Hmm, okay. I just, while starting of the session, I clearly told, after design, when the product into the process, starting of the raw material till the finished good, we are not even concerning how the raw material is coming into time or how the delivery is going to happen. We are only concerned about how this particular product is done. So design is the first stage where you visualize, imagine and create a design and come to the process. So design will not even come into things. Again, I'm repeating, this work content is completely on manufacturing aspect of a product that starts from the raw material and ends with the finished good. There is no involvement of design or the warehouse or the supply or the external logistics or the sales. It is not including all those steps. This is speaking only about manufacturing a particular component from the raw material to the finished good. You don't want to think about the previous part design and the later part supply chain. So in this, what do you feel to be the excess work content in the manufacturing sequence? One thing, maintenance. Yeah.
flaws in term or some
So delivery time.
No, that's what I'm saying. Delivery, you don't have. I'm speaking only about manufacturing aspect. Like I think Arpana, she was rightly pointing out like there is some defect in manufacturing sequence or process. Any other things? Delivery will not come in this excess work content, because again I'm repeating, it is only about manufacturing a component. Only based on that particular context, we are discussing what is basic work content and excess work content, eliminating your design sequence and supply chain sequence. Yeah.
It also
Sir,
protect the high
yeah.
quality. Getting more time.
sir, like
What is that?
so like
Sir,
we are
when we
working
have
with the
to
material and output is not what we want. So we need to process it again. So I think that is that will
Exactly.
be the excel.
Cool. Exact point. So you have designed a product and you are getting an output, but these two are not matching. The defect happens with the design. So excess work content is defined as time due to defect in design or specification of the product to the summation of time due to inefficient methods of manufacture or operations. So as excess work content is nothing is here, nothing is dealing with your design or supply chain. You have designed a component and you are processing it into a product. What is the difference? What is the defect? What is this specification mismatch you are getting in that particular context in order to match your actual design and the final product? The deficiency or the defect in design or the inefficient method or operations that you have taken, practiced, or you have done in order to get your product output, so that you again repeat the process to get your final output. That particular sequence is called as excess work content. Clear?
Yes, sir.
Cool. So now I think like you are very clear with what is basic work content and excess work content on the context of a product manufacturing. So when you think about basic work content and excess work content, you are not considering your design part or the supply part. Your only contribution is towards the manufacturing sequence, where from the raw material till the finished good, what are the defects or the mismatch that can occur with the product specification or the process sequence, that is going to give you an excess work content, and the time which you cannot reduce at all, the minimum time required that is forecasted to get one product output, one particular product as a one unit as an output, is called as basic work content, right? So now we have like this basic work content and excess work content. Now excess work content is also comes under inefficient time, right? So what do you think about inefficient time? Because something which is making inefficient in the process is bringing out your excess work content. So now how do you define that ineffective time? Ineffective time.
So to reduce the defective piece into the effective, and that much time that is required in that can be ineffective time.
Okay. Then
Time required to maintain the quality of the product, like high quality.
Not
I think
exactly.
maintenance time of the
Any other?
vehicles in which they are
Ineffective
not.
can be when workers are in rest. So when workers are
These
resting.
two I'll accept. Maintenance and workers are in rest. At least here in the excess work content, you are reworking the process. You are actually doing some correction. That is, the labor and the machine are always working in order to get the product output. This inefficient time is the time in which the worker or machine or both are idle due to shortcoming of the management or the worker.
Power failure.
So that comes with the shortcoming of the management. You didn't manage properly, so that comes with your inefficient time. About shortcoming of the worker, or how do you define? inefficient time. Inefficient time. How do you define with the worker? So shortcoming, whatever you said, like that is
Where like workers take break, that time comes in that this time, ineffective time, like tea breaks and all.
workers.
No, I'm asking, is that does that come
Yeah,
under this?
that comes, but actually we cannot, by law we cannot say that as ineffective time, because if the worker is working for 2 hours, he should be given 15 minutes break. That is in rule. So we cannot
And
say that as ineffective time. But during that 2 hours, when he is not working, that time can be counted as ineffective time. What you say is technically correct, but philosophically it cannot be accepted, because the human
moving
labor law
has
says, yeah,
consistency.
yeah.
It includes the condition.
Cool. So this particular time sequence, when the operation is happening, excluding your time for break or time for lunch, whatever it is, because technically it is right, but philosophically it is wrong, because though you work for 8 hours a day, your efficiency is calculated only for 6 hours, eliminating 15 minutes morning break, 15 minutes evening break, 1 hour lunch break, and other 30 minutes, like you may go to restroom or you may go somewhere, this that. So the effective work time is calculated only for 6 hours per day, even in an 8-hour shift. So technically speaking, what you are saying is right, but philosophically, like we cannot claim it, because labor law says that it is mandatory to have this much break when you have 8-hour shift, right? So now we come to know, like what is the difference between basic work content, excess work content, and the inefficient or ineffective time during a process, right? Any doubt till this?
No, sir.
Cool. Now we'll check to we have time. 1, 2, 3, 4 flowcharts we have. How the manufacturing sequence is completely split up. How the timing for manufacturing is made. How the work content is actually segregated based on different sequence of the process. So how manufacturing time is made. Flowchart explaining the manufacturing time. Flow chart of manufacturing time schedule, right? So first you have what you have in this particular thing, which you cannot avoid. Whatever we discussed in last slide, only that you are going to see.
Labor.
Sorry? No. We just discuss about three different things, no? From that, like whatever is there, you can see. Only with that we are going to make the flowchart.
Ineffective time, basic work content.
Okay, first comes basic work content, which cannot be avoided, right? So
Yes, sir.
basic work content of a product or and operations. So this cannot be avoided. So this will be with the glimp, like basic work contents acts as a first thing. Then what else is used to schedule the manufacturing time? Basic work contents is the first thing. Then
Excess work.
sorry.
Excess work content.
Yeah. So in
Job
excess
setup
work
time.
content, yeah, that comes everything with the basic work content, which you cannot avoid. That job setup time, everything comes with your basic work content, which we cannot avoid. That is the minimum time required to produce your product. So excess work content. So how again they are differentiated? What are the subcomponents of excess work content?
Machine and worker.
Yeah. We were discussing about two subcategories of excess work content, where the work content added by defect in design or specification, right?
Yes, sir.
Then we have work content added
Due to inefficient methods of manufacture.
added due to inefficient manufacturing methods or process, right? So this is going to give, say, let us consider like if this is component A, so this will be component B, that happens due to work content added by a defect in design. So then we have one more process sequence where we have a component C. This is added by inefficient manufacturing methods or the process, right? So these things are going to give you the total work content, right?
Yes, sir.
So the summation of your basic work content and excess work content, where in excess work content the work content added due to defect in design or specification, or the work content added due to inefficient manufacturing method, all this comes with the total work content, right? But our manufacturing sequence is not ending up with this. We have to add further to know what is the total time of operation under existing condition, like the current scenario you should know, because this is a theoretical value what you have calculated, like basic work content is the minimum theoretical value which work can be done. Then you have adding some other components called, like when there is some design defect or some process defect you have to correct it, that thing has to be added. And then comes the final thing is, sorry
Packing.
sorry
Package tag for the product.
inefficient time we were discussing, inefficient or ineffective time. So ineffective time, again we were having two subcomponents. One is due to ineffective time due to shortcoming in management, and ineffective time due to shortcoming in
Worker.
worker. So these two subcomponents will also be added to get the final job done, and we name these two as component D and E. So this is one second, sir. Classல இருக்க திருப்பி அடிக்கிறேன் sir. Okay. This is the total ineffective time. So these are the different components what you actually need to be known or to be calculated to obtain the, I'll make it as a better green. These are the normal components you should be known in order to calculate the total time of operation under working or existing condition. So this gives you the final time for producing a manufacturing product. So whatever we calculate was this much, but when you go for a practical sequence for scheduling a manufacturing time schedule, what are the things that are added excessively are something which you don't even think of, like because when you want to get a product perfectly output at the end, you should keep all these criteria in mind. Maybe somewhere your work content, excess work content on design will be good, so you will not go on with. Sometime your work content in ineffective manufacturing process will be good, the process will be too good, so you will not have added with that. Sometime your manufacturing will be good, you will have proper power backup, you have proper supply of material, you have proper assigning of labor, so there will not be any shortcoming, this will not come into picture. And sometime there will be your laborers are too good, too trained, and they are very strict to their job, they are very disciplined, they don't misuse their time, then this will not come into picture. The worst management comes when all these are existing. So as an industrial engineer, our prime focus is to consult like where we are lagging, okay, on scheduling this particular thing, to how to reduce what are the things. Anyhow, this cannot be reduced, so this is the minimum time required. How to attain this time? Say consider like this minimum work time is around 5 minutes, the total production time will be around 15 minutes. And this extra 10 minutes, how we are going to reduce it? Maybe that extra 10 minutes can be added anywhere, like with your defect in design or specification, or defect in manufacturing process, or shortcoming of your management, or shortcoming of your clerk. Anywhere this 10 minutes excess can be added, where your useful time for the process is only 5 minutes. And your prime focus will be how to get this total operating condition, total time for the operation of a particular process, by reducing the excess work content or the inefficient time which are added in your product, which are going to drag the process sequence and reduce the production and the profit. Any doubt till this?
No, sir.
Okay. Then next we will move on to work content due to product and process. Now we discussed on a overlay of about like what is work content or what is excess work content or basic work content. Now we'll discuss each and everything in detail, how each and everything can be classified and how that can be controlled in a manufacturing sequence. To discuss, to start with this discussion, we will just start with work content of a work content due to product and processes. So this again have all the components. You cannot neglect any of the components. Only thing is we will be studying in detail like how the work content can be actually scheduled without considering your a regular thing like whatever you have in your excess time or like inefficient time. So just neglecting that, we are just going to focus in depth about like reducing eliminating the inefficient time. What are the work content required, time required for both your basic work time and the excess work time added? In that we will be studying in detail. So as we discuss, our first and foremost thing will be basic work content. We don't have any choice, so we have to go with that. So basic work content will be the first and foremost thing which we cannot avoid at all. Then comes Work content added due to inefficient design or specification, work content added due to inefficient process, work content added due to inefficient process or a sequence, right?
Method.
Method, right? So now the work content of a product, how this is actually calculated. So based on this, now this work content, basic work content, we cannot do anything, that will be there. Now we are going to add work content added by defect in manufacturing, sorry,
Design or specification.
thank you, defect in design or specification. Okay, what are the things that can influence in this particular thing? What are the things that can influence in this particular contents? When you think about design, what are the components that can act in this particular thing? In detail, thinking about in detail, what will happen?
So the type of software we are using.
Okay,
Dimension inaccuracy.
yeah. Then
While making the product, the lack of attention of the labor.
exactly. Then
Machine tool and the job plan designed.
cool. So all this, whatever you say, I'll put in a technical term. Whatever you said is perfectly right, and I'll because whatever you know here, this is the actual thing which is going to add as excess work content on a defected design or a specification. But technically speaking, first thing is, of course, we blame the software, but we are not ready to blame ourselves because we are the one designing it. Software doesn't do anything on its own. Whatever the input we are giving, they'll give the actual output for that. So the first and foremost component in this work content added will be bad design of a product. Someone's joined till now. Okay, bad design of a product. So when you have a bad design, of course, everything is going to add with this work content added by the defector design. Then this should be prevented to have the most economic process. Then comes lack of standardization. What is this lack of standardization, sir? Any idea what is lack of standardization? Bad design, of course, you know, you are going to do a design in a bad way, so that is going to have an impact. Lack of standardization, what does that mean actually?
So that all the calculations that we have done, that will be same in every place where we go, like that.
Right. I'll give a better example. Everything has ISO standard and ASTM standard. International Standard Organization, they define some standard for some particular product, and American Standard for Testing and Materials, they have different standard specification for a product. So what we do is unknowingly, or we always have a myth like whatever I'm thinking is right. So we select the wrong standard, like maybe for 6 mm some standard will be there, 7 mm some standard will be there. We think we are genius and we use the wrong standard over there. For instead of 6 mm standard, we use 7 mm standard for a 6 mm product. In that condition, when you have lack of standardization, like you don't know how the standardization is happening because you are not following the actual protocol. In that condition, there is always a chance of getting defective, because like if you go for 100 mm product, that the standard says you should have given tolerance of around 0.2 mm or 0.01 mm or 1 mm. When you go for 200 mm product, the standardization says you have to give tolerance of 0.5 mm to 2 mm. But what you feel is, you think you know things better, and you put that 2 mm tolerance to 100 mm product, and 1 mm tolerance to 200 mm product, which is going to have defined, which is again going to have some defect in your design specification. That defines your lack of standardization. Then comes incorrect quality standard. This is about standardization of the product, where lack of standardization is when you design it. What is this incorrect quality standard? What is the difference between lack of standardization and incorrect quality standard that you can interpret or imagine? Lack of standardization, I say it is completely with your design when you have given a wrong tolerance limit without considering the proper standard. Incorrect quality standard.
So quality is about product. It does not include dimensions. It only includes the quality of the properties that we are using. Like the in case of shoes, so that will be the material which we are using in the production of that thing, and it
Exactly. So now
yes,
you
sir.
could understand the difference
Raw
between lack
material
of
we are using.
standardization. Exactly, the processing of the raw material. So now we understand the lack of standardization and incorrect quality standard. Lack of standardization discuss only with the design aspect, but where incorrect quality standard that completely describes with your product. What is the quality standard which is to be maintained over there from the design to product? So lack of standardization is the mistake whatever you are making with your design aspects, and incorrect quality standard is the mistake which you have done on getting your product output. So these two makes a vital difference. Lack of standardization is only dealing with your design, and incorrect quality standard is going to discuss about your component or a product. So that is the difference between lack of standardization and incorrect quality standard. Incorrect quality standard also can be done with your incorrect tools whatever you're using. So you have like some sling, what is that, vernier which is not calibrated properly, or screw gauge which is not calibrated properly, and you use that particular component, or go gauge or no go gauge which is not having proper dimensions. So in all those aspects, what are the standard measuring instruments you are going to use, that is going to play a major role in reducing the quality standard of a product what you have manufactured. Those things comes with your incorrect quality standard, right? The final product in this is excess material. So whenever you design some product, and whenever you go for machining, again you have some tolerance standard, and when you remove the excess material, once you have over material, it is very easy to reduce the material. So that's what they used to say, removal of material is a ritual product, where till you get the product you are safe, you can rework. Once you get the product, if you rework, all the standardization will change. So in that condition, if you remove excess material, then the actual rate that should be removed, that comes with your work content added by defect or design specification. So these two are going to define these two component, this work content by work content added by design and specification, and basic work content. This altogether defines what is total work content of the product. This alone defines the what is the total work content of the product. So this don't have anything with relevant to process. This added value which defines your basic work content and the work content added by the defect in your design or specification. This alone is going to have an impact, and that is giving to a definition, what is total work content of the product? I'll put forward something very plainly. Why I'm discussing everything in detail is I don't ask any direct questions mostly. I don't ask any direct question for your exam mostly. Based on your understanding, I'll ask something like that. Define excess material based on work content. Then you have to understand excess material comes under work content added by defect in design or specification. Then that comes under total work content of the product, where the total work content of the product is the combination of both your basic work content and the work content added in design or defect. So my question will be completely indirect. That is the only reason why I'm spending most of my time over here for a clear cut example or explanation. Any doubt till this?
Can you explain excess material again?
When you go for a manufacturing process, the excess material is the you have designed and you have removed a material. In material removal operation or excess material removal is design demands removal of excess material. So when you have a particular component, say 30 rod has to be reduced into 13 rod. In that, if you are what do you say? If you are quite smart, instead of going for 30 rod, you go for 15 rod, where you don't have the demand for removing excess material. You will gradually reduce the removal of excess material from 30 to 15 so only 2 material removal is required. But if you do a product for 13 and you start the material from for 30 so the removal of that 17 is going to have lot of time occurring in this process. And again, one correction that has to be controlled in this particular manufacturing process, you should be very very clear. If it is 30 to 13 till 14, you are perfect, you can get 13. Once you get 13, you cannot rework it. So you have to have that dilemma also, like, because you cannot have a scale, you can always have a higher scale on machining, you cannot have a lower scale on machining. And this excess material directly impacts when you have 13 product, you better go for 15 component initial raw material to get your product output, to reduce the demand for removal of excess material instead of using a 30 component, right? Getting?
Yes, sir.
Yes, sir.
Cool. So now this comes with your total work content of a product. So now we have one more thing, work content added by defect in
Due to inefficient methods of process.
manufacturing process / method, right? What are the things comes in this particular thing? What are the things? Now we are not going to speak about design aspects. What are the components controlled when in this context alone? Work content added by defect in manufacturing process or method. What are the things that can be added here? Alright. So first thing will be, if you choose a wrong machine, of course the manufacturing process is going to be defective. Whatever you do, whatever the things you go, if you choose a wrong machine, of course whatever the final required output you want, you will not get. Second one is process not operated correctly. It's like you have a process sequence that should be clearly defined and followed as per the standard. If you are going to follow a process which is not properly followed in a sequence, of course this also is also going to have some work content added. Like if you set like this should be set with this. Instead of this, if you set this side, obviously it is going to have some wobbling effect because this point is pointed and that will clamp your thing properly. So the process not operated correctly. So this is the process is clamping. The only thing is this has to be arrested by something. But again, instead of this side, if you put this side, this will be more legible than this. So if you are putting this side instead of this side, what will happen is if you have done the process is operated but not correctly. In that condition, this will not have proper fixture and this will wobble the effect when you consider about your machining, that is your lathe machining process, turning process. So you have to follow the proper process sequence and that should be operated in a correct way. Then you have wrong tools, right? Again, for given example, if you want to create a hole over here, it is better to use a punching machine, get a perfect hole rather than using your pen tip, because this will also produce a hole. What you do is you will do like this and produce a hole. This is also a hole, this is also a hole. So the excess work content added by defecting manufacturing process or sequence, here you are using a wrong tool. Instead of a a punching machine, you are using this pointer to create a hole. At the end you are creating a hole, but you are using a wrong tool, which is again going to add some work, because if you do like this, punching machine with no type, it creates a hole. But if you are using a wrong tool, what you will do is, for getting a correct output, you will create small, first you will make a circle, something like this, then you go for removal of the product, like sequentially 1 2 3 4 5 6 7 8 9 10 11 12 13 14. All right, now you got something which is similar to a circle. So your product, whatever the process you have done is fine, but you have unintentionally added excess time for getting this circle by using a wrong tool. Instead of this, you use this, so excess work content has been added in this, right? Then you have hello, yeah. Then you have back. Yeah, you have any doubt?
No, sir.
Good. Then comes bad layout. Yeah, bad layout is, again, you go with the manufacturing sequence. I'll put the manufacturing of this one. The cap should be at the final stage. The thread should be at the third stage. The holding should be, the molding should be at the first stage, and after this threading, this should be at the third stage. Instead, if you put clamping of this, whatever you have here, before your product, because these both comes with a particular sequence. So what you do is, instead of threading in second stage, if you do threading in the third stage, and if you put the cap in the second stage, it is the bad layout design, whatever you have done. So what you have to do, again, if you have shut the machine like that, then this machine has to move on to the third product, do the threading, and come back to the second stage and do the capping. This is the simple example for bad layout. Like when you are going in a process sequence, when you are not aware of what will actually happen with the process, so when you misplace the machines, the layout for your manufacturing sequence, again that is going to add excess work to your component or a product. And finally, where's that pen? This pen, okay. Finally, you have operatives bad working methods. This everyone do, because again, when you consider leveling of thing, when you clamp and unclamp, if you have a bowl spanner, you can put it, and if you have excess place, you can just hold at the other side and roll it, so that it fastens easily. Instead, what people will do, like normal spanner, they'll put, do this, put, rotate, put and rotate. Though the tool is having, or the method is having a proper sequence in order to reduce the time, but the operator is working in a bad way to get the product output. I'm giving you a simple example again. There are two types of spanners. One is bowl spanner, which is round in type, and one is like the spanner in something like this. I think I have that component. 1 minute. Yeah. Sorry. You could see this?
Yes, sir.
Yes, sir.
So this is your bowl spanner, whatever you have, and when you have excess space, this will fix to the bowl easily, and you can easily rotate like this. But in this spanner, you cannot rotate like this, because here you have an opening. Once you rotate, it will come out. So what people have the mindset is, like, they are used to this particular type of spanner, not this particular type of spanner. And this was printed in our 3D printing machine like a long way back, like I just trying out something. They have the practice of using this particular side of spanner. So what they do is, they hold like this, they put like this and turn around, they put like this and turn around, they put like this and turn around. Even then, when they get this bowl spanner, what they do, instead of putting and rolling it completely, though they have the space, they have the habit of doing like this, putting like this, turning around, taking it out, putting like this, turning around, taking it around, putting it like this and turning around. In that, though the process sequence is perfect to get a required output, the operative bad working method, the operator's bad working method is again going to add excess time to your manufacturing process or the method. So these are the different things which controls your work content added by the defecting manufacturing process or method. So this complete thing is called as total work content. So the work content of the product is only with your basic work content and the design and standard thing, whatever is time added in this standard process. But the total work content is the summation of all this component, including the work content added in defective in manufacturing processes. Any doubt till this?
No, sir.
Okay. Apart from that, we have ineffective time. So that thing we will discuss in detail. Only till this, the total work content is, then comes your ineffective time. That thing we will discuss in next class. Next class we will just try to do some three layouts we have. We'll try to go over that, and with that we'll wind up basic and excess work content. Then we will directly move on to work study and human factors. Right, you can post your attendance. If you have any doubts, you can ask.